We're going to take notes for section 10.9. The first definition is going to be of circumference, which I know is a repeat, but let's write it again. So the circumference of a circle is its perimeter. The formula for circumference would be circumference equals pi times diameter, or you can say circumference is equal to 2 pi r, where r is the radius. Arc length. Arc length is a linear measurement similar to the length of a line segment. The length of an arc depends both on the arc's measure and on the circumference of its circle. Theorem 98 states that the length of an arc is equal to the circumference of its circle times the fractional part of the circle determined by the arc. So the formula, and I'm going to put it below. So the arc length equals the arc measurement divided by 360 degrees times the circumference. So let's do an example of that. Find the length of a 40-degree arc of a circle with a 36 centimeter diameter. We know that the circumference is equal to 36 pi because the diameter was 36 centimeters. The arc is 40 degrees, so we're going to say the arc length is equal to 40 over 360 times the circumference, which is 36 pi. So we can do some simplifying. Realize this is on top, so you can put it over 1. We know that 36 and 360 are both divisible by 36, so this would go to 10, and this would go to 1. And then if I have 40 over 10, I can make this 4, and this go to 1. So all that's left would be 4 times 1 times pi, which would be 4 pi, and that's all over 1. So that would be your answer, and don't forget your units that are centimeters. So the arc length would be 4 pi centimeters. Next one, example 2, find the length of a 30-degree arc of a circle with a 12 centimeter radius. So this time we're given the radius, which is 12 centimeters. To get the diameter, we would double that, which would be 24 centimeters. Okay, if we have a 30-degree arc, the arc length would equal 30 over 360 times the circumference of 24 pi. So 30 and 360 can be simplified to 1 over 12. And then if you multiply across, you have 24 pi over 12, which can be simplified to 2 times pi. So we have 2 pi centimeters for the arc length. Next page. This one is similar to the ones we've already done. We have a radius that is 25, and we have an 105-degree arc. So we would say the arc length, would equal 105 over 360 times the diameter would be 50. So your circumference would be 50 pi. So let's start to simplify this. 105 and 360 can actually be simplified to 21 over 72. So if we multiply that across, well, before we even do that, we can still simplify it even more. So 3 goes into both 21 and 72. So let's simplify this now to 7, and this goes to 24. All right, so it's getting a little messy, so let's multiply across. We can have 7 times 50 pi over 24. And before I completely go across, I know that both 50 and 24 are divisible by 2, so I can do 25 here, and I can put 12 down here. And then from there, we can multiply across because we're done simplifying. 7 times 25 is 175 pi on top, and then 12 on the bottom. And there were no units given, so that is your final answer. Example 4, the diameter of a bicycle wheel, including the tire, is 27 inches. How far will the bicycle travel if the wheel rotates 1,000 times? And approximate your answer in feet. So first, let's write down what we know. We know that the diameter is equal to 27 inches. Well, first of all, they want us to approximate our answer in feet. So let's convert 27 inches to feet. So in order to do this, I'm going to multiply by the conversion factor. And if I want to get rid of inches, which is on top, I'm going to put inches on the bottom. And then I want to change it to feet, so I'll put feet on the top of the fraction. So here we know that 1 foot is equal to 12 inches. So what we're really doing, since inches is on top and bottom, it crosses out. And essentially what we're doing is we're dividing. We're taking 27, multiplying it to 1, which is just 27, dividing it by 12. So you end up with approximately, well, actually exact 2 1/4 feet. From there, we know that the diameter is 2 1/4 feet, so the circumference is going to be 2 1/4 pi feet. So that means the perimeter circumference is 2 1/4 pi feet. Now, they want to know how far are you going to go. If I rotate, that's 2 1/4 times pi, 1 rotation. I need to know how far is it going to go if it's 1,000 rotations. So I'm not going to draw it 1,000 times, but we're going to take 2 1/4 times pi and multiply that by 1,000 times. So we get 2,250 pi, which is approximately 7,069 feet. Part B is asking how many revolutions will the wheel make if the bicycle travels 50 feet, which is a lot less than 7,069 feet. But we know that 1 revolution would mean 2 1/4 pi feet. So how many revolutions? We don't know. Would it take to travel 50 feet? This would be your setup. Then to solve for x, we would divide by 2 1/4 pi, divide by 2 1/4 pi. Make sure you are using the pi button, not 3.14, because that will make your answer less accurate. So when we solve for x, we end up with 7.07, which means that it's approximately 7 revolutions or turns in order to travel 50 feet. Okay, there's a lot of repeats on this page, so forgive me, but I'm going to skip around a lot. Example 1, it wants you to find the circumference of a circle with an area of 120 pi. So since they gave you the area is equal to 120 pi, well, the formula for an area would be pi r squared equals 120 pi. So we can get rid of pi on both sides, and we have the radius squared is equal to 120. Therefore, the radius is equal to the square root of 120. 120 can be broken down into the square root of 4 times the square root of 30, which would be 2 root 30 for the radius. Now for the diameter, we would double that. So the diameter would be 4 root 30, and they are asking to find the circumference. So the circumference would just be 4 root 30 times pi, and you don't leave it looking this way. You take everything that's not underneath the square root, that's not part of the radicand, and put it in front. So we get 4 times pi times the square root of 30, everything left. So that is the circumference when the area is 120 pi. All right, we've already talked about the length of an arc, and example 2, we've already done ones like that where they want you to find the length, and you know the arc is a certain degree. The only thing, you wouldn't be able to do this unless they told you that the radius or the diameter equaled a certain amount. So you would need that information. One thing, example 3 is very similar to the one we did. So let's move on to example 4 and on this back page. So example 4 says find the perimeter of the figure. So the perimeter would be 4 plus we have this semicircle of the circumference there, plus another 4, and then a larger semicircle of the circumference there. So what we really need to do is we need to essentially find this arc length as well as this arc length to figure out what our perimeter is. Let's begin with the larger arc. So the diameter for that one would be 4 plus 3 plus 4. So the diameter would be 11. The circumference would be 11 times pi. However, that would be for a full circle. We only have a half of a circle. So we're going to take 11 pi and divide it by 2. For the blue arc, we know that the diameter is 3 and the circumference is 3 pi if it was a full circle, which it's not, so we're going to take 3 pi and divide it by 2. Now, to find the perimeter, we're going to add up all of those pieces. So the red arc is 11 pi over 2, plus this 4, plus the blue arc, which is 3 pi over 2, plus the last piece, which is the other 4. So 4 plus 4 would give you 8. 11 pi over 2 plus 3 pi over 2 would give you 14 pi over 2. Simplify that to 7 pi, so your final perimeter length would be 8 plus 7 pi. If it had units, you would put that in parentheses and write units. On to the last problem. This is a challenging problem, but I'm going to walk you through it. Please know that we will do this type of problem again in class tomorrow, so it's good to get exposure right now though, so that it's not the first time seeing it tomorrow. We want to know, we have 2 pulleys that are connected by a belt. The radii of the pulleys are 3 centimeters and 15 centimeters, and the distance between their centers is 24 centimeters. Find the total length of the belt needed to connect the pulleys. So when they talk about a belt, they're talking about the belt going around the 2 pulleys. And the other information we have is that the radii are 3 and 15. So from here to here it's 15, from here to here it's 3. We could also draw this down here. This is 3 and this is 15 as well. We are going to have to draw the common tangent twice. And technically you're just drawing the common external tangent problem twice on the same picture. So let's connect B and E. And we know that the right angles go with the radius and the external tangent. We do not want to make the right angle here in the center. That's a big no-no. All right, so this should look familiar. We're going to make a rectangle. So to do that, I'm going to extend this line here, and I have a bunch of right angles. So if I know this side is 3, then the opposite side of the rectangle would also be 3. But 3 plus what gives you 15? This portion would be 12. And I realize they're not drawn to portion. So the last bit of information they told us was that the centers, I'm going to draw the centers in yellow. So this is 24. So I'm going to take out this right triangle. So I'll draw it down here. not going to be perfect, but we have 12 and we have 24. So if you can see that this is x and this is 2x. So because we know that, we now can figure out that we have a 60, 30, 60, 90 triangle. So 30 would be over here at x, the 2x would be across from the right angle, and then this across from the 60 would be x root 3. So that means that this would be 12 root 3. That's this other leg, which we need that out here for the outside of the pulley. So we essentially have two sides that are 12 root 3. So to start adding up the length of this belt, I'm going to take the 2 and multiply it by 12 root 3, because you have the two 12 root 3s right here and right here. But I have this arc length to add into the belt length and this arc length to add into the belt length. So how are we going to do this? Well, if we go back to this triangle, we know that it was a 30, 60, 90 triangle. And at this point, I'm going to draw the same rectangle and right triangle on this side. So these are the right angles. If that's 60, this is 60. It's just the mirror image. And if this is 30 right here, then we're going to have 30 degrees right here. So those two would be the same. So if I have to find the arc length of this, I need to know this arc measurement, which a full circle is 360 degrees. But we have to take away these two 60s. So 360 take away 120 would leave you with 240 degrees. So from here to here, it's 240 degrees. So you know how to figure out the arc length. We have 240 over 360 multiplied by the circumference. And the circumference would be the diameter times pi. Well, you know that the radius is 15. Therefore, the diameter is 30. Circumference, you'd multiply that by pi. So let's multiply across. Let's simplify a little bit. So get rid of the zeros. 24 and 36. 12 goes into both of those. So we can go down to 2 over 3. And then 30 pi and 3. Those can be simplified to 1 and 10. So now let's multiply across. We have 2 times 10 times pi, which is 20 pi. And that is the arc length right here. So that's part of the belt. So let's add that in down here. We have plus 20 pi. Okay, the last bit that we need is this arc length over here. So we know that this angle is 30, this angle is 30. If I am looking for the arc length from here to here, I need to figure out this angle measurement. So together these are 60, and then I have a 90 and another 90. So altogether we have 90 plus 90 is 180 plus 60 is 240. So this angle is 240, meaning this angle must be 120, because 360 take away 240 leaves you with 120. I'm going to do these calculations in red down here. So we have 120 over 360 times the circumference. Well, we know the radius is 3, therefore the diameter would be 6 multiplied by pi to get the circumference. Cross out the zeros and start simplifying. So we get 12 and 36, they're both divisible by 12, so we get 1 and 3. And then 6 and 3 can be simplified to 1 and 2. You end up getting 2 pi. And that is the arc length right here, which is part of the belt. So we need to add that measurement into the final belt length. And now we're going to simplify. So 2 times 12 root 3 would be 24 root 3. Plus 20 pi plus 2 pi is 22 pi. And that would be the length of your belt. 24 root 3 plus 22 pi centimeters. This concludes your notes for the day.